To use the substitution method to solve systems algebraically, these are the steps. You don't have to copy them right now because this document is always in Google Classroom. You can leave some space and then copy them later on. But the first step is to solve one of the equations for one of the variables. Any one of those two equations. We have two equations. One of those two equations had to have either x equal to something or y equal to something. You want to have an equation like this. It could be solved for x or it could be solved for y. It doesn't matter. But one of the equations must be in this form. If we notice here in number 1, the second equation is already solved for y. So this is step number 1. We don't need to do it here for the first system because we already have one of the equations solved for one of the variables. The second equation is solved for y. You want to have something like this, definitely. So if you don't have this, then you need to do this step. In this case, we do not need to do it. And then step number 2, substitute one equation into the other equation and solve the resulting equation. So what we're going to do is take this equation that is solved for x or for y, in this case solved for y, and put it into the other equation. We're going to put that into the other equation. How are we going to do it? We're going to substitute the y value in this case because we know what the y value is equal to. We have the y value. The y value is 2x minus 1. So where we see the y, we're going to put this that is equivalent to y. So that's going to go here. That's the second step. Substitute one equation into the other. So I'm going to do the substitution. And I'm going to rewrite the first equation because the substitution will be done into this equation. So I'm going to be rewriting this equation. 4x plus 3 is equal to 27. And now I'm going to substitute y. Everything else will remain the same. So 4x is going to remain the same plus 3. But the y is going to be substituted with what's equal to y, and what's equal to y is 2x minus 1. And then we have equal to 27. So the only thing that has changed is the y has been replaced by its value. Of course, we keep the original operation. The original operation is 3 multiplied by the value of y. So here we're going to be multiplying 3 by all this. So when you do the substitution, you have one equation like this one. This equation is going to have only one variable now. So the variable y has disappeared because we substituted it. And then we only have the variable x in this resulting equation. So now we're going to solve this resulting equation. Of course, we're going to be solving it for x. That's what it says in number 2. Substitute one equation into the other and solve the resulting equation. This is the resulting equation from the substitution, and now we need to solve that. So we're going to do step number 2. How do we solve an equation like this? Yes, we're going to distribute here the 3 times the 2x and the 3 times negative 1. Remember that when we are distributing here, we're multiplying. So we're going to keep the 4x for the moment here. That's going to be 4x. And then 3 times 2x, how much do we get there? Yes, so it's positive 6x because 3 is positive and 2x is positive. So the result of the multiplication is positive 6x. And now 3 times -1, what do we get from that? Anthony, what do we get from that? Yes, so that's -3, because we're multiplying a positive times a negative, that's negative, and 3 times 1 is 3, equal to 27. Now we know how to solve these type of equations. We learned that the last semester, and the way to do it is just to separate variables on one side and put the numbers on the other side. So we can remove this from here and put it to the other side. Always it goes with the inverse operation, because that is equivalent to adding 3 on both sides. So we should be adding 3 on both sides, or this one just goes to the other side by adding. So if we do that, on the left side of the equal sign is going to be left 4x plus 6x, and on the right side is going to be 27, and then the 3 is going to come adding to the other side, which is the same as adding 3 here and here. Only I'm writing it horizontally here and not on the left side, but it does the same thing. I'm going to be erasing this part. So now we combine the like terms that we have. 4x plus 6x, how many x's do we have over there? Yes, that's 10x. And on the right side, 27 plus 3 is 30. Yeah, so that's 30. And in order to solve for x, we need to remove the 10. The 10 goes divided into the other side, or what we usually do, divide by 10 on both sides. Notice that I'm using different methods here. I just moved this to the other side, which is like a method that is used in other countries. Usually here we like add 3 to both sides, but here I'm using the method that we use here in the US. It's dividing on both sides by 10, and x is equal to 30 divided by 10, 3. So this is the value of x. We're not finished, because step number 3 says substitute the value. It's talking about the value that we got here. Substitute the value into one of the equations and find the value of the other variable, because we only have the value of x. We need the value of y. Why do we need that? Well, because when we solve systems, remember that we're looking for that point where the two lines intersect, because that's the solution for a system, is the point of intersection. And the point of intersection has coordinates x, y. Right now, we only have the x coordinate, so we now want to find the y coordinate. So we're finding that coordinate when we're doing this procedure, only we're not doing it by graphing, but we're doing it with an algebraic procedure. So we have the x coordinate, now we're going to find the y coordinate. What is y equal to? And to do that, we do a step number 3, which is take one of the equations that you have here, one of the original equations. Any one is going to give us the same answer, but I always use the easy one, the simple one. Which one is the simpler one over here, the first one or the second one? Yes, the second one is simpler. It has smaller numbers. There's one variable that doesn't have a number next to it. And not only that, notice that we're finding the value of y. We want to find the value of y, and this is already solved for y. So you are not going to need to like move things from one side to the other side. The only thing that we need to do here, if we use this equation, is simply substitute the value of x and simplify the right side, and we're going to get the value of y. Now, if we use this one, there are more steps to do. You're going to substitute the value of x, and you're going to move this to the other side, and then divide by 3. Still an equation that you should be able to do it, but I always use the easiest one, the simpler one. So I'm going to take that equation, which is simpler, which in this case is the second one. Y is equal to 2x minus 1, and then I'm going to substitute now the value of x that we found here, which is 3. So we have now y is equal to 2 times 3, because that was the original operation. 2x means 2 multiplied by x, so 2 times 3 minus 1. 2 times 3 is 6, minus 1 is 5. So the value of y is 5. And now we have our coordinates x and y. So this should be our solution. The point that is formed by the x and the y values. So solution 3, 5. First the value of x and then the value of y. And if you were to graph these two lines should be intersecting in 0.35, unless there is a mistake in the procedure that we did here. So any questions up to that point? Any questions? No questions? Okay, I'm assuming that there are no questions. Now, the procedure that we didn't do when we were doing graphs last week is the check. When we solve an equation, we should always check, or in this case, solving a system, we should always check to make sure that this solution that we got is indeed the solution, that this is correct, the procedure that we did is correct. And we do the check by substituting the values of x and y into the equations. It has to be done, the two checks, because we have two equations. If this is the solution for the system, it has to work with both the equations. So with both equations, so we have to check both of them. We're not going to be doing the check for every single one because we just don't have the time to do it, but we're going to do it for this one so that we can see at least how do we do it. It's the same as with any other equation. Substitute the value of x and see if you get something that is true. You should get the two sides equal, because that's what the sign says. It says that the two sides are equal. So we should get the two sides are equal in both equations. So let's do the check for 4x plus 3y is equal to 27. The value of x is 3. So substituting here the 3, and the value of y is 5. We're going to substitute here the 5. Of course, we have multiplications here. So we should have 4 times 3, which is the value of x, plus 3 times 5, which is the value of y, and that simplified should be equal to 27 if this is correct. So we're going to do that. 4 times 3, that is 12. 3 times 5, that is 15, and it is positive because here everything is positive. And that should be equal to 27, and indeed it is. 12 plus 15 is 27. So we have 27 on the left side, and on the right side we also have 27. So we have the two sides equal. This is true, and so we know that at least it works with the first equation. So it checks for the first one. We need to make sure that it also checks for the second one. So the second equation is y is equal to 2x minus 1. The value of y is 5. So here we substitute with 5. The value of x is 3. Here we substitute with 3. And we simplify, we should get the two sides equal if the solution is correct. So 5 for the value of y, 2 times 3, because x is 3. And we simplify the right side. 2 times 3 is 6. 6 minus 1 is 5 on the right side. And on the left side, we also have a 5. So I'm just bringing down this 5. we get something true, 5 equal to 5, and that proves that it checks for the second one, and that proves that this is correct. So this is indeed the solution, because it checks with both equations. And that is the complete procedure. This is the solving procedure, and this is the checking. Checking to make sure that the solution is correct. Any questions with this one? Anthony, any questions? Okay, and Honey, any questions? Okay. Okay, now we're going to do the second one. The second one is not ready for the substitution. Here, this was ready for the substitution because one of the equations was solved for one of the variables. In this case, we don't have one of the equations solved for one of the variables. We don't have x is equal to something or y is equal to something. So you take the simpler equation and solve for one of the variables. So in this case, what can we do? Which equation can be solved for one of the variables? Any ideas? Okay, no ideas. That's fine. What we can do is, for the second equation, we can solve for x. Why? Because the x is already alone. So the only thing that I need to do is take this negative 3y and move it to the other side. It's going to go adding to the other side, and that's it. That's going to leave x equal to something here. And then we will be ready for the substitution. We are going to substitute this equation now into the first equation, but we're going to substitute x here, not y. Here we substituted in the first one, we substituted y because we had the value of y. Now we're going to have the value of x equal to something, so we're going to substitute the x here. So always look for what is the best thing. If there is a variable that doesn't have a coefficient or the coefficient is 1, like the x, well, that's the equation that's the variable that has to be solved for. So take this and move it to the other side, which is the same as adding 3 to both sides, adding 3y to both sides. So that's going to be plus 3y plus 3y. That's just going to give us positive 3y is positive 3y plus 1. So that's 3y plus 1. Or simply, I'm bringing this with the inverse operation, which is a positive, and then the 1 is staying positive. And that's it. That's the value of x. Now I have the value of x, and now I can substitute into the first equation. So we're going to substitute the value of x. So I'm going to rewrite this equation here. That is 2x minus 2y is equal to negative 6. Substitute the value of x. That's going to give us 2 times, because it's a multiplication, 3y plus 1, because that is the value of x, is 3y plus 1. Everything else remains the same. That's going to be negative 2y or minus 2y is equal to negative 6. And that is the resulting equation. The x has disappeared. We only have an equation with one variable, and now we can solve this equation. So we do the same thing that we did on the top, distributive properties. So we're going to be distributing 2 times 3y, that's going to be 6y. 2 times 1, that's going to be plus 2. Remember that we're multiplying. And then we bring down the negative 2y equal to negative 6. The next step, separate the variables on one side and the numbers on the other side. So that's going to be 6y minus 2y is equal to -6, and then this 2 that is adding here, it should go subtracting on the other side, because what we're really doing is we're subtracting here the 2 and the 2 here. That's what we're doing here. I'm just doing it a different way. How much do we have left on the left side? 6y minus 2y is yes, 4y. And on the right side, -6 minus 2 is -8. And now, what do we do to solve for y? Yes, we divide by 4. We always divide by this number that is next to the y, which is multiplying with the y, so it goes dividing to the other side. And so yes, that's 4 divided by 4, that's 1y, and -8 divided by 4, that is -2. So in this case, we have found the value of y first. Up here in number 1, we found the value of x first. That's okay, it doesn't matter. We just are going to find the other variable, in this case being the value of x. What is that value of x? And for that, we always use the simplest equation. In this case would be, again, the second one. Use the original equation, which is x minus 3y equal to 1. We're going to substitute now the y because that's what we have. So x is equal to 3 times -2 is the value of y that we just found. Simplify this, negative times another negative, that becomes positive. So it's x plus 6 equal to 1. And now we subtract 6 on both sides, or just take this to the other side by subtracting any way that you want to do it. We should be able to change from one way to another way, but subtracting 6 to both sides, that's what we're doing. So x is equal to -5. So that's the value of x. So now we can write our solution. The solution is the value of x first, -5, and the value of y second, which is -2. So if we were to graph these two equations, these two lines will intersect in point -5, -2. We're not going to do the check just because of the time, so we're going to stop here with the examples, and now you're going to do the practice exercises. Any question with this one?